Welcome to Spring LIB.
This is a good question that reviews several concepts in this chapter and concepts from preceding chapters. We have a chemical reaction of iodine pentafluoride being created from iodine solid and fluorine gas. The balanced chemical reaction is this shown here, where 1 mole of iodine reacts with 5 moles of fluorine gas, producing 2 moles of iodine pentafluoride. If we have 10 grams of iodine and 10 grams of fluorine, we can calculate the amount of product that can be created using limiting reactant principles. We'll calculate the amount of product that can be created with each reactant, and the one that produces the least amount of product will be the limiting reactant, and the amount of product that it creates will be the amount of product the reaction creates. If we have 10 grams of iodine, we can calculate the moles of iodine by dividing by the molar mass of iodine. Then we can go from moles of iodine to moles of the product, recognizing the stoichiometry of the balanced chemical reaction, 1 to 2. When we have moles of iodine, this will then give us the moles of the iodine pentafluoride that can be created from the 10 grams of iodine. Let's now do the same thing with the 10 grams of fluorine. Convert the grams fluorine to moles fluorine by dividing by the molar mass of fluorine, F2. Then convert the moles F2 to moles iodine pentafluoride, recognizing it's a 5 to 2 relationship, and we'll get 0.10527 moles of the product iodine pentafluoride. Because the iodine produces the least amount of product, it is the limiting reactant, and the amount of product actually created is the 0.0788 moles. Okay, this is still not the answer to the question. It wants to know the partial pressure of the product iodine pentafluoride. Well, to calculate the partial pressure, we need to know the ideal gas law, and we need to know the moles of the product that is created, along with the temperature and volume. The temperature and volume are provided. Volume is a 5-liter flask, and the temperature is 125 degrees Celsius. So using the ideal gas law, PV equals nRT, rearrangement will allow us to solve for pressure as nRT over V. N is the moles we just calculated up here. We'll multiply that by R, multiply that by T, which is the temperature, but not in Celsius, in Kelvin, so we need to add 273 to the 125. And then divide by the volume of the flask, which was given to us at 5 liters. This gives us 0.515 atmospheres of pressure created as the partial pressure of the product, iodine pentafluoride. There's still pressure created, so this is not the pressure inside the flask. There's still additional partial pressure created by the unreacted fluorine. Fluorine is not the limiting reactant, so it's not consumed completely. Part B then asks us, what is the mole fraction of IF5 in the flask? To calculate the mole fraction, we need to figure out how many moles are still present of F2. This can be determined by calculating the moles of F2 we start with, and then subtract off the moles that reacted. We can calculate the moles we start with by taking the mass divided by its molar mass. We'll calculate the moles that reacted by figuring out how many moles of F2 we needed to make 0.0788 moles of the product. We'll take 0.0788 moles of the product and then convert to the moles of F2 required to make that amount of product using the stoichiometry of the balanced reaction, 2 to 5. So the moles initially we have, minus the moles that reacted to make the product, give us the moles left over, 0.06618 moles. So the mole fraction, that is IF5, will be the moles that's IF5 divided by the total moles of gas, which is the moles IF5 plus the moles of F2 that didn't react. And this mole fraction then is 0.544. Okay, now for part C. This is a review question from a previous chapter. Draw the Lewis structure for IF5. To draw the Lewis structure, we first need to count up the valence electrons that are available for the structure. 7 from iodine, 7 from fluorine, but there are 5 of them, gives us a total of 40 valence electrons. We'll put the atom found once in the middle, iodine, surround it with the 5 fluorines, bonding each fluorine to the iodine. We then just used up 2 times 5 to make the 5 bonds, 10 valence electrons, so we have 30 left over. If we add 6 more to each of the 5 fluorines, that uses up the remaining 30, and this would be the Lewis structure for fluorine pentafluoride. The last part of this question asks for the total mass of the reactants and the products in the flask. Now, there's a hard way to do this, and there's a very, very easy way to do this. The hard way to do this would be to figure out the mass of fluorine that is left unreacted, figure out the mass of iodine that's left unreacted, which would be 0 because it's the limiting reactant, and then take the moles of the product, this right here, and calculate its mass, and then sum everything together. That would then give you the total mass of everything in the flask. However, the easy way is to recognize the law of conservation of mass. The law of conservation of mass states that mass is neither created nor destroyed in a physical or chemical process. This is a chemical process. So if we start with a total amount of 10 grams iodine and 10 grams fluorine, we have a total amount of 20 grams. It doesn't matter what happens in the chemical reaction. We're not going to create any more mass or destroy any mass. So we start with a total of 20 grams, the reaction ensues, we're still going to end up with 20 grams of reactants and products when the reaction is done.